Welcome everyone to lesson number 1 of Unit 2, Graphing and Analyzing Quadratic Functions. So let's take a look at what a quadratic function looks like numerically. You see it right here. We have f of x equals ax squared plus bx plus c. What makes this function a quadratic is the fact that we have x to a second power. Okay, our first term is called our quadratic term. Our b term we refer to as the linear term, and our c we consider to be our constant. There is one thing that we got to be sure of here though. It's that we can't have a equaling 0, because if we did, we would be eliminating the quadratic term. We'd no longer have a quadratic function. It'd just be plain linear. What we want to check out now is what the graph of a quadratic function usually looks like. We should know by now from algebra 1 and 2 that it's a parabola. Okay, so that's the general shape of our function is going to be parabolic. But what's interesting is a few things about this, right? First of all, parabolas are symmetric. So we have right here, drawn in this dotted line, is what we're going to be calling the axis of symmetry. We'll talk about that in one moment. Okay, next you have this point right here, the vertex. We've talked about this in past lessons before, and in algebra 1 and algebra 2. That's where the vertex, or that's where the parabola starts changing direction, right? So you notice that here it's going down to a certain point, the vertex, and then it starts changing direction and going back up. That's our vertex. We also have a couple of other really interesting points, right? We have the Y-intercept, where the function crosses the y-axis. And because we have an axis of symmetry, we know that on both sides of that axis, the distance between the axis and the function itself should be equal. So whatever length this happens to be here, we would have the same distance over here, which is very useful because we can figure out the exact location of this point because it's going to be the same height as our y-intercept. It's going to be the same distance away from the axis. So we can really just count or even double if we know the axis itself. Okay, so we'll be able to get not just the vertex and y-intercept today, but we'll also be getting this third point, which helps us to draw the actual parabola itself. Okay. Let's take a look at a couple of useful formulas that we're going to want to know. Write these down somewhere because we're going to be referring to them throughout this lesson. Okay, first, the axis of symmetry itself. We're going to find that by taking the b value, dividing it by twice the a value, and then multiplying it by -1. The vertex, as you noticed in our image before, the axis of symmetry runs through the vertex. So for our vertex formula, it makes sense that our x-coordinate would also be the axis of symmetry. Okay. As far as our y-coordinate, well, we're going to evaluate the original function at x to figure out what y would end up being. Okay, so we're just going to evaluate whatever we get here, and that'll be our vertex. Then you have the y-intercept. The y-intercept is just going to be the c value of our function, whatever the constant happens to be. Okay, and then we have two more things we're going to talk about, the minimum and maximum. The minimum, which we'll recognize when a is positive, we'll visually see that as the parabola opening up. Okay, then we also have a maximum when a is negative. We'll notice the parabola opening down. What a minimum and maximum are, it's either how high up the parabola is going to be going, which would be maximum, right, at the top value, or our minimum, how far down our parabola goes. In the image that we had up here, we notice that it's going up forever and ever, but it goes down to a certain point. That's the lowest value it will ever be. That would be our minimum. We also see that our function is positive, which means that it's going to be a minimum, and we can see that it's opening up. Okay, all those things that we described with minimum. Okay, so we're just going to want to decide what our minimum or maximum value is, which is really nice because it's also going to be your y value of your vertex, right? Our vertex is the lowest point here, so it makes sense that it would be either the minimum or maximum. Alright, so we went over a lot of things. We're going to see how each of these work in practice. Okay? You're going to need some graph paper for this. So if you need to download some graph paper from the website, or if you've got some already on hand, draw yourself a 10 by 10 coordinate plane. And what we're going to do is we're going to find the axis of symmetry, the y-intercept, the vertex, the min-max value, and then we're going to graph. And we're going to get the graph mostly from a few of these things here. Okay, so let's start from the axis of symmetry, which we need both because it's part of the problem and because we need it for the vertex later. Okay, our formula for axis of symmetry is we want to do -1 times our b value, which here is -4, divided by 2 times the a value, which here is 2. We've got a negative times a negative. Those are going to eliminate. So we're left with 4 on top. 2 times 2 gives us 4 on bottom. So our axis of symmetry is going to be x equals 1. Now I'm going to go over to my graph right now, and I'm going to graph that. It said x equals 1. So I'm going to go to my x value. Let's do that in a different color so we can see it better. Okay, I'm going to go to 1 on our coordinate plane, and we're going to draw a vertical line at 1. Okay, there's our axis of symmetry. Right. For the y-intercept, it's just whatever our c value is. Here, our c value is -2. So we're just going to write that down because they ask for it. Right, y-intercept, we have 2, -2. Okay, if we were doing that in a coordinate, it would be 0, -2. So we're going to want to graph that as well. Okay, we'll do the graph in green. How about that? So we want 0, -2, which is right here. That's going to be our y-intercept. Now we had said, looking at that other picture that we had, that because we have an axis of symmetry here, we know that the distance from the y-intercept should be equal on the other side. Right? So I already know my y-intercept right here is at -2. I can see that I have a distance of 1 between my axis of symmetry. So I'm also going to go 1 unit on the other side, and that's going to give me my second critical point. Well, all I need now is my vertex, and that will tell me which direction this thing's going to go and where the vertex should be. I already know it's going to be opening up, so hopefully our vertex should be down here somewhere. Let's see what we end up getting. Okay, for the vertex, we already know our x-coordinate is 1. So what we need to do is evaluate the function at 1. So we have 2 times 1 squared minus 4 times 1 minus 2. 1 squared is going to give us 1, times 2 is 2. -4 times 1 is -4, and minus 2. Let's see, 2 minus 4 is -2, minus another 2 is going to give us -4. So our vertex, we get 1, -4. That's also our minimum value, right? Because we knew that this was going to be a minimum, it's a positive value, and we knew that it was going to be whatever our y happens to be, so we can also list that as well, because they look for that in our instructions. Minimum is going to be -4. So let's see, we want to point 1 and -4, we want to plot that right here. So now I have the critical points I need. I'm going to try to do my best to make sure that they're pretty even on both sides. There we have our graphed function as well. Okay, not too bad. A couple of things that we needed to do, but they were all pretty simple. Right? And if we follow the formulas, they're easy enough to work with. Okay, we're going to try this problem out. So you're going to need another 10 by 10 coordinate plane. Take a moment to write down the function as well. Okay, we're going to do the same set of instructions, right? Find the axis of symmetry, y-intercept, vertex, min-max value, and then graph. I can already see that we have a negative. That means we're going to have a maximum value. Okay, so that's something that we want to keep track of. Okay, first we're going to find the axis of symmetry. Axis of symmetry. It's going to be x equals negative our b term, which here is 8, times 2 times our negative 1, which is our a value. Okay, so we've got x equals 8 over negative 2. These negatives are going to end up canceling out, and we end up with x equals 4. That's our axis of symmetry. Okay, I'm going to come right over to our graph at 4. Here's 4. I'm going to just make my axis of symmetry. Next, they want the y-intercept. Our y-intercept is always our c value. Here it's negative 7. So our y-intercept is going to be 0 and negative 7. Let's plot that really quick. 0, negative 7 is right here. We should remember now that we can go from our y-intercept, count over to our axis. That's 4 units away, so I want to be 4 units away on the other side. That's going to put our next critical point right here. Then we want the vertex. I'm going to be evaluating f at 4, because that was what our x coordinate was. So we have negative 4 squared plus 8 times 4 minus 7. 4 squared is going to give us 16 times that negative. We've got 8 times 4, which is 32, all minus 7. When we combine all of that, we end up getting 9. So our vertex is going to be 4, 9. Also, they want the min-max value. We already said that this is going to be a max because it's negative. So our max value, you can just call it max, is going to be 9. Right? Our y value is our min-max value. Right, so let's see. 4, 9 is right here. It's right on our axis of symmetry. And all we need to do now is connect our vertex to each of these points. It should be somewhat of a curve, so do your best to make it a curve. I know mine doesn't look like it. I was never very good at drawing them anyways. So there's that. Okay. We have a problem now for you to try out. Let's see what you picked up from this lesson so far. Okay, you're going to need another 10 by 10 coordinate plane. This is going to be a you try problem, so you're going to write down the instructions and the function, and you're going to try it out. After you pause the video, do your work, resume when you're ready to check your answer, okay? All right, let's check out how you did with this. So same instructions as before, right? Axis of symmetry, y-intercept, vertex, min-max value, and graph. And here's the function that they give us. A couple of things we want to identify right away, right? We have already identified that it's going to be opening down, right? It's going to be upside down, and it's going to be a max value. we also identified our y-intercept right away. Okay, we'll write that down in a moment. Okay, but let's see. If we want to do axis of symmetry first, we're going to do x equals negative. We want our b value on top divided by 2 times our a value, which is -1. Let's see, that's -4 on top, -2 on bottom. Our negatives are going to cancel out. 4 divided by 2 gives us 2. So our axis of symmetry is 2. Let's see. Here's our axis of symmetry on our graph. Next, they ask us for the y-intercept. We found that a moment ago, right? We identified it as 2. So our y-intercept, we're going to be at 0, 2. 0, 2. That's our y-intercept. Okay, I can see where our axis of symmetry is right here. So I'm going to count from our y-intercept over 2 and then over 2 on the other side. That's our other critical point. Okay, next we need to find the vertex. Vertex. We're going to evaluate the function at 2, or at our x value. So we want negative times 2 squared plus 4 times 2 plus 2. 2 squared is 4, and we still have that negative, so it's going to be -4. 4 times 2 is 8, and when we combine those things, we end up getting 6. So our vertex is going to be 2, 6. That also helps us out with our max, right? We knew that it's going to be a max because it's negative, and we know our y value now, so we're going to say max of 6. The highest point on the function is going to be 6. It won't get any higher up than that. So let's see, let's graph our vertex. That's 2, 3, 4, 5, 6. That's 2, 6 right there. And we're just going to connect. Okay, graphing parabolas or quadratics, not too difficult when they're in quadratic form. As you can see, we just need a few things: the axis of symmetry, y-intercept, the vertex. Those few things really help. Hope that this lesson was easy enough to follow for you. If you have any questions, you just leave them on the comments or bring them into classes even better, and we can discuss them there.